At the start of the 21st century, a rapidly rising demand for radioactive waste characterization from the UK nuclear decommissioning sector began to place major strains on specialized laboratories providing radioanalytical capability. This increased demand was created by the progressive closure of first-generation nuclear power plants on 12 UK sites that had come to their end of life. It was also evident that, within a decade, analogous pressures were to be expected internationally. The challenge for the industry and associated laboratories was to be able to process, sample and analyze the significantly increased volume of wastes generated during the dismantling of these plants. Meeting this challenge demanded innovative radioanalytical solutions to efficiently and accurately characterize radionuclides in the voluminous low to medium level wastes expected. This radionuclide characterization is a crucial part of the process of waste sentencing, as it guides which treatments to use that could lead to reductions in both the volume of radioactive waste and its significant disposal costs. One method to achieve this reduction was through an understanding of radioactivity depth profiles determined through systematic sample core drilling of key structural materials such as concrete and steel. For example, in the laboratory, concrete cores are subsampled by slicing, then analyzed for their radionuclide components to generate accurate contamination depth profiles for each depth increment. If radioanalytical results from these profile samples show that only surfaces were contaminated, then these can be selectively and physically removed using engineering methods like scabbling for concrete or shot blasting for steels. The physically removed contaminated surface, normally representing only a small fraction of the original, could be stored as radioactive waste with a significant cost benefit. The remaining, much larger volume of uncontaminated material could be categorized for free release and then either recycled or disposed of at low cost. Raddec International was established in 2003 by radioanalytical specialists Dr. Ian Croudace and Dr. Phil Warwick, at a time when there was a rapidly rising demand for novel, cost-efficient radioanalytical instrumentation. Croudace and Warwick had fortuitously invented their innovative Pyrolyser instrument 3 years earlier for extracting various species of tritium along with carbon-14 from estuarine sediment. This was part of a UK government research contract focused on understanding the environmental fate of industrial tritium discharges that had entered the Severn estuary from 1982 to 1998. Based on scientific interest arising from Raddec's published papers and conference presentations, it was quickly recognized that the versatile pyrolyser could benefit the burgeoning nuclear decommissioning sector. Sales of the system increased sharply based on the capability and strengths of the instrument. Most particularly, its ability to automatically control the desorption and collection of tritium and carbon-14 from 6 samples simultaneously. Later, R&D showed that not only tritium and carbon-14, but also chlorine-36 and iodine-129 could also be efficiently extracted, further extending its capability and reputation. Since its introduction over 20 years ago, Pyrolyser technology has been adopted internationally as the industry standard instrument for extracting volatile radionuclides. Its impact for the nuclear decommissioning sector has led to millions of pounds being saved through its step-changing analytical efficiency and contribution to waste reduction. The Pyrolyser system has shown that their inherent flexibility facilitates the handling of a complex range of samples encountered during nuclear decommissioning. The instruments also show that they can analyze a broad range of environmental samples such as soil, sediment, and biota in environmental laboratories. Following the success of the revolutionary Pyrolyser Trio series, Raddec has continued to lead as a producer of innovative radioanalytical hardware and software solutions. 3 notable instruments have been added to Raddec's range. The Pyrolyser Mini was developed for specialist laboratories requiring operation in a fume cupboard or other containment systems. In addition, a new advanced multifunction version is also under development with UK nuclear industry funding. This is designed to remotely run high-activity samples within specialized containment systems. The HBO2 is a closed-system oxygen bomb device developed for laboratories needing to rapidly oxidize large combustible sample sizes up to 40 grams. It has found application in both soft waste characterization for the fusion science sector and for environmental tritium monitoring. The ASRS provides automatic chromatographic separation of radionuclides and elements from acidic solutions. It is aimed at laboratories focused on increasing their analytical workflows and elemental separation reliability, whilst simultaneously reducing their labor overhead. The ASRS is a joint enterprise with South Korean colleagues. Additional to its innovative hardware developments, Raddec has also produced a range of successful software products to assist laboratories in analytical data processing and visualization. These include LIMS, an integrated laboratory information management system for professional radioanalytical laboratories. LSC+, which facilitates the rapid processing of liquid scintillation data, whilst minimizing the potential for transcription errors. And iTrax Plot, which is designed to rapidly visualize the high volumes of iTrax core scanning data. Raddec: knowledge, innovation, solutions, service. Raddec's success is based on innovation and expertise in methods for the characterization of nuclear and environmental materials. For further information, please see the detailed video and PDF media available for each of our products at www.raddec.com. The entire suite of high-definition video media is also available on our YouTube channel. You can contact us directly at sales@raddec.com.